Welcome back, everybody, to another deep dive. Today, we're going to be unpacking this book, Introduction to Software Design Patterns, Bridging Principles and Paradigms. And we're going to be talking about software design patterns. You know, they're almost like the secret sauce of software development. It's not the ingredients themselves, but it's how to combine them in a way that just works.
Yeah.
So by the end of this deep dive, you're going to know what they are.
Yeah.
And you're going to know why they're important. And this is true even if you've never written a line of code.
That's right. It's kind of like seeing the elegance behind the scenes, right?
Yeah.
So, design patterns are reusable solutions to common problems in software development. Think of them like blueprints.
Okay.
But not for a building, but for code.
Okay, so it's like if you're building something, you don't have to reinvent the wheel every single time.
Exactly.
You can just go back to this library of solutions that have worked in the past and use those.
That's right. They're like time-tested and proven.
So it's a little bit like using pre-made Lego sets, though, right? Like, where's the creativity if you're just kind of pulling from the same bag of tricks every time?
So I think it's more about having a framework.
Okay.
Imagine that you are an architect. You wouldn't redesign a door every time you build a house.
Sure.
You'd probably use a pattern for a door, but adapt it to the specific house.
Yeah.
Design patterns work the same way. They're adaptable templates,
Okay.
not rigid code snippets.
Okay, so it's about capturing the essence of a solution without just like copying and pasting, right?
Exactly.
You still have some creativity there, but you're not just like blindly doing things over and over again.
Yeah, and you're leveraging the experience of, all the developers who came before.
Yeah. I see the value in that, but why should someone who isn't a programmer care about this?
Because they embody the principles of good design.
Okay.
And, good design is everywhere. It's not just in software. Understanding design patterns helps you appreciate how complex systems are built, how they adapt, and how they remain stable over time.
Okay, so it's almost like you're saying, even if I'm not an architect, I can still look at a building and tell if it's well designed, even if I don't know the specifics of like how they built it.
Exactly. You're starting to recognize like recurring motifs, clever use of space, and how everything just works seamlessly.
Yeah.
That's the beauty of design patterns, and they the same elegance to software.
So in a way, understanding design patterns is like appreciating the craftsmanship behind the software.
Absolutely.
Even if we don't know the nuts and bolts of how it works.
Yeah, and it can also make you a more informed user.
Okay. How so?
So, for example, if you understand the observer pattern, you might notice how a change in one part of an application triggers updates in other parts, like in a stock trading app.
Yeah.
That's the observer pattern at work.
Cool, yeah, so it's like you start to see under the hood a little bit. Okay, but before we go on a pattern hunt, let's break down the basics. What are the main categories of design patterns and how do they differ?
So there are three main categories: creational, structural, and behavioral.
Okay.
Each addresses a different aspect of software design.
So it's kind of like different teams on a construction project.
Exactly.
All right, so walk me through them. Creational patterns first. What's their area of expertise?
They focus on flexible object creation.
Okay.
Instead of hard coding the creation of every object, they provide mechanisms to create them dynamically based on specific needs. Imagine a factory that produces different car models based on customer specs.
All right, so it's not like they're building a car from scratch every time.
Right.
They have like systems in place to build different types of cars based on what the customer wants.
It's about having a blueprint.
Got it. What about structural patterns? What do they bring to the table?
They deal with how objects are composed and how they relate to each other.
Okay.
Ensuring that different parts of the system work together harmoniously.
So it's all about organization and relationships.
Exactly.
Now on to the last category, behavioral patterns. What makes them tick?
They're all about how objects communicate and collaborate with each other.
Okay.
Defining the flow of information and actions within a system.
So they dictate how objects interact to achieve a common goal.
That's right. Think of a social media app that notifies multiple users about a new post. That's the observer pattern at work.
So one action triggers a cascade of responses.
Exactly.
This is already giving me a whole new perspective on how software is designed.
Yeah.
But are these patterns just random recipes?
That's a good question.
Or is there a deeper connection to the underlying principles of good software design?
That's where things get really interesting.
Okay.
Design patterns are not just arbitrary solutions. They're deeply connected to fundamental principles like the solid principles,
Okay.
which emphasize code clarity, flexibility, and maintainability.
So it's not just about having cool tools, it's about knowing how to use them properly.
Yeah. Think of it as having a master architect guiding your design decisions.
Okay, I'm with you so far, but how do these principles actually translate into specific patterns?
Sure.
Can you give me a few examples?
Absolutely. Let's consider the single responsibility principle,
Okay.
which states that every class should have one and only one reason to change.
So, like, each component has a clearly defined role.
Right.
Avoids those messy situations where everything's tangled up.
Good guide.
And that makes updating the software easier.
Mm.
What about the open-close principle? How does that play out in the world of design patterns?
That principle states that software entities should be open for extension, but closed for modification.
So you should be able to add new functionality without changing existing code.
Precisely. A great example of this is the strategy pattern.
Okay.
Which allows you to define a family of algorithms and encapsulate them in separate classes, making them interchangeable at runtime.
So it's like having a toolbox of algorithms you can swap in and out as needed.
Exactly.
That sounds incredibly flexible.
It is.
Are there other examples where we see this interplay between principles and patterns?
Certainly. The dependency inversion principle encourages decoupling high-level modules from low-level implementations.
Okay.
This is reflected in the dependency injection pattern, where dependencies are provided externally
Okay.
rather than being hard-coded within a class.
So it's like having interchangeable parts in a machine, right?
Yes.
You can swap out components without breaking the whole thing.
That's right.
I'm starting to see the bigger picture here. But let's get down to brass tacks. Can we explore some of these popular patterns in action?
Of course.
See how they work in the real world.
Yeah.
Let's start with the singleton pattern. Can you give me a real-world scenario where that shines?
The classic example is a centralized logging system for an application.
So instead of having logs all over the place, you have a single point of access.
Exactly. It ensures that all parts of the application log to the same place.
That makes sense. What about the factory method pattern?
Consider a document editor that can create various types of documents.
Okay.
The factory method would be used to create these different document objects
Okay.
based on the user's selection.
So instead of having a different creation method for each document,
Right.
you have one factory that handles it all.
Exactly.
This is fascinating stuff. I'm curious about the adapter pattern.
Okay.
That one sounds like it could be really useful in bridging the gaps between different systems.
You got it. Think about a situation where you need to integrate two systems that use different interfaces.
Mm-hmm.
The adapter pattern acts as a bridge, allowing them to communicate seamlessly.
So it's like a universal translator for software.
Precisely.
Okay, I can't wait to hear about the observer pattern. It sounds like it's all about staying in the loop.
Imagine a stock trading app that updates you in real time about price changes for your favorite stocks.
Okay.
That's the observer pattern in action.
So it's like having your own personal stock ticker,
Yeah.
constantly keeping you informed.
That's right.
Okay, one last pattern for this, around the strategy pattern.
Okay.
How does it work in practice?
Think of a navigation app that lets you switch between driving, walking, and cycling routes on the fly.
So it's like having different algorithms for different navigation needs.
Exactly.
You can adapt to different situations seamlessly.
Yes.
But I have a feeling we've only scratched the surface here.
You're absolutely right. There's a whole universe of design patterns out there.
Well, then it sounds like we need to keep this deep dive going. So stay tuned for part 2, where we'll delve even deeper into this fascinating world of design patterns.
Welcome back to our deep dive into design patterns.
Yeah.
Before we jumped into, you were saying you're excited about the universe of patterns out there.
Yeah.
Shall we explore some more?
Absolutely. We touched on a few other names before, like the composite, the state, and the mediator.
Okay.
Let's start with composite. What's the core concept behind that one?
The composite pattern lets you treat individual objects and groups of objects uniformly.
Okay.
So think about a file system on your computer. You can interact with a single file and an entire directory which holds multiple files.
Okay.
Using the same set of operations.
There's like those Russian nesting dolls where you can have like one inside the other.
Exactly.
But you interact with each of them like the same way.
Yeah.
Okay. What about the state pattern? How does that one change the game?
Imagine a vending machine.
Okay.
It can be in different states. Waiting for money, dispensing a product, or displaying an error message.
True.
The state pattern lets the vending machine change its behavior based on its current state.
So it's like the vending machine is wearing a different hat.
Yeah.
Depending on what it's doing.
Yeah, almost like it's changing its class dynamically.
Okay, that's really cool.
Yeah.
Okay, last one from our break teaser. The mediator pattern. What's the magic behind that one?
The mediator pattern promotes loose coupling between objects by introducing a central hub for communication.
Okay.
So think of an air traffic control tower at an airport.
All right.
Instead of having pilots communicate directly with each other, they communicate with the tower, which coordinates their movements and prevents collisions.
So it's like a conductor for an orchestra, making sure everybody's in sync.
Exactly.
Yeah.
Yeah.
It sounds like a great way to manage complex interactions.
Mm-hmm.
This is really expanding my understanding of how software can be structured.
Yeah.
But I'm curious, are there patterns beyond these three categories?
Yeah.
What other fascinating patterns are out there?
Oh, there are a lot more. Let's talk about chain of responsibility.
Okay.
This pattern allows you to pass a request along a chain of potential handlers.
Okay.
Until one of them can handle it.
Okay.
So imagine submitting an expense report at work. It might go through various levels of approval, your manager, then their manager, and so on.
Okay.
Until it reaches someone who can authorize it.
So it's like a relay race for approvals.
Exactly.
Okay, what about flyweight?
Flyweight.
Does that have something to do with like lightweight software?
In a way, yes. The flyweight pattern is all about minimizing memory usage by sharing common objects.
Oh, okay.
Picture a word processor that needs to display a document with thousands of characters.
Okay.
Instead of storing each character individually.
Yeah.
Flyweight shares common characters like letters, numbers, punctuation, reducing memory overhead significantly.
So it's a resource optimization strategy.
Exactly.
Okay, I like that. Another one that I'm curious about is the command pattern.
Okay.
What's the command in this case?
So the command pattern encapsulates a request as an object.
Okay.
Allowing you to parameterize and queue requests.
Okay.
Think of a voice assistant, like Siri or Alexa. When you ask it to play a song, your request is transformed into a command object that the system can execute.
So it's almost like the to-do list for the software.
Exactly.
Very cool. So what other intriguing patterns are hiding in our software?
There are patterns like visitor, which allows you to add new operations to a hierarchy of objects without altering their structure. Think of a compiler that needs to perform different operations on different parts of a program.
Okay.
The visitor pattern provides a way to do this without modifying the program itself.
Okay, so it's like you have a specialized tool that can interact with these objects without having to change them.
Precisely.
Pretty neat. What about the interpreter pattern? How does that one interpret things?
The interpreter pattern defines a grammatical representation for a language and provides an interpreter to deal with this grammar.
Okay.
Imagine a system that needs to evaluate mathematical expressions.
Okay.
The interpreter pattern could be used to define the grammar of these expressions.
Okay.
And provide an interpreter to calculate their values.
So it's like you have a mini language processor built into the system. Okay. One last one. The template method pattern. What's the template here?
The template method pattern defines the skeleton of an algorithm in a base class.
Okay.
Deferring some steps to subclasses. Imagine a reporting system that generates different types of reports, sales reports, inventory reports, and so on.
Okay.
The template method would define the overall structure of the report generation.
Okay.
But allow subclasses to customize specific steps, like data retrieval or formatting.
So it's like having a recipe, but there are some customizable steps.
Yeah.
You can tweak things without changing the fundamental dish.
Precisely.
This is making me feel like a software detective.
Yeah.
Uncovering these hidden patterns everywhere I look. But we've covered a lot of ground here.
We have.
Can we step back and reflect on the bigger picture for a moment?
Of course, it's important to remember that design patterns are not just about memorizing a catalog of solutions.
Yeah.
They're about understanding the underlying principles of good software design.
Uh-huh.
And how those principles translate into concrete, reusable solutions.
So it's about developing a mindset, not just learning the code snippets.
Exactly. It's like learning the art of problem solving, not just memorizing the answers.
Yeah.
It's about recognizing recurring patterns and problems and applying the wisdom of those who came before us.
Yeah, and it never stops.
And it's a journey of continuous learning as new patterns emerge and existing patterns evolve.
This has been an incredible journey so far, and I'm eager to see what other insights await us in the final part of this deep dive.
Welcome back to the show. We've really gone deep on design patterns, haven't we?
We have, yeah. From creational patterns making object creation easier, to structural patterns keeping things organized, and behavioral patterns making those interactions smooth, we've really seen how well-designed software ticks.
Yeah, and we've seen how those patterns really line up with the solid principles.
Right.
Clarity, flexibility, maintainability, all that good stuff.
Yeah, it's almost like we've been given a secret decoder ring for software design.
Mm-hmm.
But as we wrap this all up, why does this all matter if someone never writes code?
That is a great question. Understanding design patterns, it goes beyond software. I think it's about recognizing those elegant solutions that work no matter what you're doing.
So like even if you're building a house or planning a trip,
Exactly.
you can still use these same ideas of efficiency, flexibility, robustness.
Yeah. They might be different patterns, but those principles, they still apply.
Design patterns really show how smart people are, figuring out common problems and coming up with those elegant solutions that can be used over and over again.
It really is like tacking into this collective wisdom.
Yeah. But let's bring it back to software. Now that our listener knows a bit about design patterns, how can they use this in everyday life with technology?
Start paying attention to how software behaves. Notice how different parts of an app work together. See how data is managed, how it handles what you do. Look for those patterns.
So almost like becoming a software detective.
Yeah. Find those clues that reveal the design patterns underneath.
And once you start seeing them,
you get it.
You start to see the thought, the effort.
All that craft that goes into making good software.
You also start to see where software falls short.
Oh, absolutely. You'll know when something's poorly designed, when it goes against those principles we talked about.
And you'll be able to say why. Like, instead of just saying this app is clunky, you can say this app has tight coupling, or this design, it doesn't follow the single responsibility principle.
Exactly. You've got the words, the ideas to understand and critique the software that you use every single day.
And that helps you make better choices, right?
Absolutely. You can pick software that's designed well, that's easy to maintain.
Yeah.
Software that fits what you need.
This has been a great journey into design patterns. We've just scratched the surface, but hopefully you, the listener, can keep digging deeper.
Design patterns are more than just code. It's a way of thinking, solving problems elegantly and efficiently.
Keep your eyes open, be curious, and you'll see those patterns everywhere. Happy pattern hunting, everyone.